Welcome to the lesson on skewness. By the conclusion of this lesson, you're going to be able to compute and interpret the coefficient of skewness. And we're really going to be looking at the whole concept of what is skewness. So when we're talking about skewness, what we're really talking about is the shape of data. There's symmetrical, positively skewed, negatively skewed, and bimodal. When it's symmetrical, what you're really looking at is the symmetry of data. Does the left side match up with the right side? It's kind of like if you were to fold a piece of paper in half. Are the two sides of the piece of paper symmetrical? If it's positively skewed, the data that we're looking at, then the mean is greater than the median. If it's negatively skewed, then the mean is less than the median. And then also with positively skewed data, the probability of occurrence tapers off towards the positive end of the horizontal or the positive end of the vertical axis. And if it's negatively skewed, the probability tapers off towards the towards the negative end of the horizontal or vertical axis. And if it's bimodal, then there is really high probability on the exterior of the distribution and lower probability on the interior of the distribution. And we'll be talking about that a little bit later. I know what I just said is a lot of information, and I'm not you'll hear a lot more about it later and get to understand that a bit more later. So with skewness, the way that we determine skewness is we calculate the coefficient of skewness, and the formula that we use to do that is Pearson's coefficient of skewness, which is 3 multiplied by x bar minus median, or the mean of the data minus the median of the data, divided by the standard standard deviation. So what we're going to do is we're going to calculate the mean and the median really quick, specifically of the data in our survey. How much money do you think you will spend on fast food this week? So the first thing that we're going to do is equals average, and then we're going to highlight all the data. And notice there are a total of 103 data points or observations. So now we're going to do equals median of the 103. Okay, and I see 103 rows right down in the bottom. Okay, so the mean is 20 and the median is 28. So already we know, based on this information, let's see if we can zoom in a little bit. We know based on this information, if the mean is greater than the median, then it is positively skewed. But we want to know how positively skewed it is. Okay, so what we're going to do now is we're going to calculate the standard. The standard deviation. And the way that we do that is equals the data point minus the mean, and let's put a $sign, and then we are going to drag it up. Okay, and then we are going to square it, equals, and the reason why we're squaring it is to get rid of the negative. Okay, and then right here we are going to get the sample variance. And remember, with the sample variance, what we do is we do equals sum, and we add all of these together. Okay, sum, and we're going to put a parentheses right there, put a parentheses right there, and we are going to divide it by 103 minus 1. And the reason why we do 103 minus 1, it's n minus 1 is the formula for the sample variance, and we do that just to be a little bit more conservative with our results, as we are assessing a sample and not the actual population. So 747.537 is the variance, and then we take the square root, equals square root of the variance. to give us our standard deviation. Okay, so in order to get the coefficient of skewness, which I've already calculated right here, we do equals in parentheses 3 multiplied by, and then we highlight 3 multiplied by the median, or sorry, the mean minus the median. So the mean minus the median, and then we divide that result by the standard deviation, which is right here, and that gives us the skewness coefficient of 0.91. So this means that it is slightly positively skewed. And it may look like it's more than slightly positively skewed, but when we are interpreting a coefficient of skewness, anything between -1 and 1 is considered to still be within a normal distribution, or more of a symmetrical distribution. But if you get into the 1 to 3 or -1 to 3, then it is more positively or more negatively skewed than what we really want to work with. And skewness, really what it does is, if it's too skewed, it makes it so that the data, when we do statistical analyses, the statistical analyses can't be trusted as much. So we need to make sure that the data is within the 1 to -1 range. Okay. So let's take another look at another example. Okay. So all of these, if you want to pause this and enter this into a spreadsheet, I've already entered it into a spreadsheet right here. The first thing that we need to do is calculate the mean equals average. Take the average. Okay, then we're going to equals median. Okay, and then we are going to equals subtract the mean from all of the observations. So x minus the mean. And then we are going to square it to get rid of the negative. And drag it down. And then once again equals sum, except we're going to do parentheses first. Sum. Okay, divided by parentheses 15 minus 1. So if you look, 15 minus 1, once again there's a total of 15 observations, but this is only a sample, so we need to do 15 minus 1, and then equals square root of 27.2668, and that gives us 5.22 is the standard deviation, or the square root of the variance. So then we do equals 3 multiplied by the mean minus the median, and then we divide that by, divide that by the standard deviation, which gives us 1.017, and so that is going to be a positively skewed distribution. And if you want to take a look at this, you can highlight more of a visual representation of this. Highlight this and do insert, recommended charts, and let's go to all charts, and we're going to do a box and whisker. Okay. So you can see that the this right here is the mean. This line right here is the median. The mean is greater than the median, and this side of the box is much greater than this side of the box. And so you can see how the distribution is really high right here, but then slowly tapers off towards the positive end of the vertical axes. So that is what we conclude about it. Normally we can just tell right away based on the mean and the median, but we can tell whether or not it's positively or negatively skewed just by looking at the mean and the median. So if I ask you a question, and I give you the mean and the median, you should be able to right away tell me whether or not it's positively or negatively skewed, or if they're the same, if they're symmetrical. And then you can do the variance or the standard deviation to determine the skewness of the data. So that right there is skewness. I know that's a lot of information, and frankly, it's kind of difficult right now because there's not a lot of places for you to apply this. We're not actually going to be applying this until the third unit, really. So just hang on to this. We'll be talking about normal distribution, a little bit in probability as well. So hang on to this information, and we'll reference it here and there throughout the remainder of the course.